WPA, as we saw earlier, was a stopgap measure. It was put in place while awaiting the completion of IEEE 802.11i. Eventually, 802.11i was ready, and then the Wi-Fi Alliance moved on with WPA2. WPA2 and 802.11i introduced the concept of a robust security network, or RSN. Therefore, you might sometimes see this term RSNA algorithm or pre-RSNA algorithm. Algorithms related to 802.11i and WPA2 are known as RSNA algorithms. They are the ones that provide this higher security. And then pre-RSNA algorithms like WEP then are being phased out. In fact, 802.11i was mostly implemented in WPA, except that it was still using RC4 but with stronger key mixing. Finally, with WPA2, the introduction of a stronger block cipher came into the picture. This is known as AES, Advanced Encryption Standard. In WPA2, AES is used operating on blocks of 128 bits. So what happens is that you have an input of 128 bits, and that 128 bits of encrypted output comes out. The question is that how do we then use a block cipher like AES when we need to have a stream of data coming in and a stream of data coming out? Because our frames are much longer than 128 bits. There are multiple ways to convert block ciphers to so-called stream ciphers, which will support this streaming of input and getting a stream of output cipher text. And so therefore we see this CCMP, which is talking about the way that AES is used, basically how it's converted to a stream cipher, both for confidentiality and for integrity protection. For confidentiality, it uses AES in so-called counter mode, and for integrity, it uses CBC MAC. Therefore, we have CCMP, which is counter mode with CBC MAC protocol. For confidentiality, counter mode is one of the ways to convert a block cipher to make it a stream cipher, and in fact it's a recommended way. It's one of the two recommended ways of doing it, even though there's multiple schemes like ECB, OFB, CFB, and so on. ECB is electronic code book. Each of these has their acronyms. One of the advantages of counter mode is that both the encryption and decryption are parallelizable. This is a very useful property to have, because then it's better for the hardware to be able to compute in parallel. Meanwhile, as far as data integrity is concerned, a much enhanced data integrity mechanism is introduced. It's known as CBC MAC, and one thing I need to note here is that CBC MAC stands for Cipher Block Chaining for Message Authentication Code. We will see what cipher block chaining is in a couple of minutes. But first, this term Message Authentication Code. Because we have people coming from two areas of expertise, one is security and cryptography, the other is data communications, sometimes we see problems with acronyms. MAC from the cryptography world stands for Message Authentication Code. Message Authentication Code is a way of doing data integrity protection. You authenticate that the message has not been modified using Message Authentication Code. It's a way of doing data integrity protection with a key and then doing some ciphering on that. However, from the data communication world, MAC often stands for Medium Access Control. So we talk about the MAC layer of Wi-Fi, for example. In the Wi-Fi specs then, we see that this is then called MIC, Message Integrity Code. But it's just terminology. So to be clear then, well, when you see CBC MAC, you know what it's referring to, depending on whether you're from one community or the other community. Okay, then we have each block of plain text being XORed with a previous block of ciphertext. We will see a block diagram, and I think that makes it easier. In either case, AES is used with a 128-bit key and 128-bit block size as the building block for both of these confidentiality and data integrity protection. CBC MAC is shown here. Cipher block chaining, so we see the chaining happening here. So we have encryption happening block by block, and then the ciphertext then is XORed. So this 128-bit of ciphertext is XORed with the incoming plaintext in the next block. And then you have the key as well. So this is the cipher block chaining. That's why it's called this. Eventually you end up with a very powerful MAC, or message integrity code. Counter mode, on the other hand, does not do that kind of chaining. So as we see here, each block of ciphertext then does not have to go into the next block encryption. And each block of plain text is XORed with something that comes out with a counter. So that's why we have the counter mode, and then we have the key. Here then is a picture of CCMP as used in WPA2. We see a transient key. So again, it's not the master key that's being used, but something that's derived. So this is something that even in WPA we saw, better than WEP. Then we have a packet number for replay protection, because it's just like the TKIP sequence counter in WPA. And we see that now we have the CCM encryption using AES, stronger than RC4. And the MIC here, as mentioned in the data communications world, we want to avoid using MAC for the same for message authentication code.